So we've already talked about how to find probability, simple probability, that probability and probability or. We worked a lot with that the last time we looked at probability. Today we're going to be looking at something called sample spaces. So if you remember our probability fraction, the bottom of it is that total possible. And that total possible, believe it or not, is our sample space. All the possibilities that are available. In most of the probability questions that we did earlier, that total possible was an easy number. Like we knew there were 10 marbles in the whole bag, or we knew that there were 52 playing cards in the deck. But sometimes, especially when they are talking about a lot of combinations, trying to find that total possible before you can find probability can get a little bit confusing. So today in class, we are going to look at 3 different methods for finding that total possible outcomes, that sample space. Now, there are 3 ways that you can find the sample space. You can create a list, and sometimes that looks like writing it all out. Sometimes you can do it like a table like that. You can make a tree diagram, or sometimes people call this a branch diagram, or you can use the counting principle. And we are going to look at all 3 of these ways, but we're going to focus mostly on the counting principle because especially as you get into bigger combinations, counting principle can be your best friend. But let's go all the way back to list. Making a list is exactly what it sounds like. You just think in your head about all the possible combinations and you write them down. For example, if our question is how many possible outcomes are there if I toss a coin 2 times? Well, how many sides does a coin have? It has 2 sides, right? Heads or tails. So I could toss a coin and the first time it could land on heads. And then it could land on heads again for the second time. Or I could toss a coin and the first time it lands on heads and the second time it lands on tails. Or I could toss a coin and the first time it lands on tails and then it lands on heads. Or I could toss a coin and it lands on tails both times. So how many possible outcomes? There are 4 possible outcomes. Making a list can be really nice because you've got all of the different parts right in front of you. And if we're only talking about a coin, the coin only has 2 sides, tails or heads, and we're only tossing it 2 times. That's a pretty good one to do a list on. But the more possibilities that are available, the longer the list is, the easier it is to miss a possible combination. So think about this second question. How many possible outcomes are there if I choose a combo meal consisting of a drink, and that drink could be milk or water or soda, a main menu item like a hot dog, burger, or pizza, and a dessert item like ice cream or cake? Well, if I would do a list like I did with my coin toss, I would have to go hot dog, milk, ice cream. Hot dog, milk, cake. Hot dog, water, ice cream. Hot dog, water, cake. Hot dog, soda, ice cream. Hot dog, soda, cake. And that's just the hot dogs. And I could very easily miss one. In fact, fact, I think I did. Look, I did hot dog, soda, ice cream 2 times. That should be hot dog, milk, ice cream. There's one mistake. And I hadn't even gotten through all the hot dogs yet. Then you have to go into burgers. Burger, milk, ice cream. Burger, milk, cake. Burger, water, ice cream. Burger, water, cake. It just goes over and over again. And because I cut and pasted, I missed a burger, milk, cake. So I've already got 2 problems with this. So the longer the list, the more likely it is that we're going to mess it up. So the list may not be our best option if there's a lot of different things to think about with it. We can make a tree diagram. So when we're reading a tree diagram, our categories are up and down. So if we go back to our coin toss, the coin has 2 sides. So this would be my first time tossing it. It could be heads or it could be tails. Then this would be the second time tossing it. It could be heads or tails again. And then when we're looking for the different combinations, we've got heads, heads, or heads, tails. Tails, heads, tails, tails. So they're all there just like they were in the list. They're just written a little bit differently. If we want to say how many possible combinations, we take the farthest right column and we just count down how many there are. So we have 1, 2, 3, 4, and we still answer there are 4 possible combinations. So a tree diagram can be really helpful when it's something like our menu item and our beverage and our dessert, because now I can have my main menu item. I can do all of my drinks. So I'm going to repeat them each time because the hot dog needs milk, water, and soda, and the burger needs milk, water, and soda, and the pizza needs milk, water, and soda. And then my next column, I can put in my desserts, cake or ice cream. And to find out how many possible combinations, we go to the far right column and we count down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 different combos that we could order just from this group of stuff offered. So a list is really good if it's just a couple of things that you're looking at. A tree diagram can be much more helpful if you've got a complicated list of things. You just need to remember how to set it up. The last method is what we call the counting principle. So when we use the counting principle, we're going to be multiplying. And we're going to look at how many options are in each category or event. So let's go back to our coin toss. How many possible outcomes are there if I toss a coin 2 times? So we're looking at events and it happened 2 times. So there will be 2 numbers that we are going to multiply. The numbers that go inside the boxes are the possibilities in the tosses. So with this first toss, we know it could be heads or it could be tails. So there are 2 possibilities. Well, we didn't change the coin at all. It's still heads or tails for the second toss. So there are still 2 possibilities. 2 times 2 is 4 possibilities. We got the same answer, whether we did the list, the tree, or the counting. Always we got to the 4. It just is a matter of which one works better for that scenario. Let's try the counting principle with our menus. So when we're looking at drinks, well, let's go back. Now we're looking at how many options, right? We have drinks, we have main menu items, and we have desserts. So that means we have 3 numbers we are going to be multiplying. This first one I could say is my drinks. There's milk, water, or soda. There are 3 options. The main meal item, a hot dog, a burger, or pizza, there are 3 items. The dessert has 2, and 3 times 3 times 2, do it in your head or do it in the calculator, we get to 18 possible combinations, which is exactly what we got when we did it with the tree diagram. Go ahead and pause the video here, and you try this next one on your own. See how you do. Did you give it a shot? This one has a little bit of a trick, right? We're not putting the card back. So we're looking at events. It happened 3 times, so that gives us 3 boxes. And the amount of cards that I'm drawing from in the first one are 52. But I don't put that card back. So the second time I draw, I'm only drawing from 51. And I don't put that card back. So the next time I draw, I'm only drawing from 50. And I am so glad that we have a calculator, because our answer would be 132,600 possible combinations. Could you imagine trying to do that answer in a list or even in a tree diagram? That'd be horrible. The counting principle helps us, especially when we're moving into a lot of different possibilities. So let's go into our practice problems. If you turn the page, you should see question number 1 starts with the Grimaldis. And we're going to look at this Grimaldi situation, and we are going to solve it with all 3 methods, just so you can see them again in action. And then later on, we're just going to use the counting principle to solve some of the others, and then I'll let you work on some by yourself, and you can use whichever method you like the most. Before the Grimaldis, they have 3 children born in different years. How many possible arrangements of boy and girl children are there in the family? So we're looking at birth order, right? Well, if we're going to list, we got 3 different children, boy and girl birth order. So they could have had a girl in the beginning, and then another girl, and then another girl. They could have had a girl, and then a boy, and then a girl. They could have had a girl, and then a boy, and then a boy. They could have had a girl, and then a girl, and then a boy. Or they could have had a boy first, and they could have had a boy, and a boy. Or they could have had a boy and a girl and a boy. Or they could have had a boy, a girl, and a girl. Or they could have had a boy, and a girl. So if we count up how many possible orders, 1, 2, 3, 4, 5, 6, 7, 8 possible arrangements, doing it with the list. Now, if we want to do it with a tree, remember we're thinking about, in this case, events. The first child could have been a boy, or it could have been a girl. The next child would be our next branches, and it could have been a boy or a girl. The third child still has the same options. It could have been a boy or a girl. So we've got oldest, middle possibilities, youngest possibilities, and when we count them up, we still end up with 8 possible arrangements. Counting. We have 3 different events: first birth, second birth, and third birth. In the first birth, the oldest child, it could be a boy or it could be a girl. So that is 2 possibilities. The second is the same 2 possibilities. And the third is the same 2 possibilities. And 2 times 2 times 2 gets us to 8 possible arrangements. Go ahead and pause the video if you need to. Look at what we've done. See if it makes sense or if you need to go back a little bit and rewatch this part again. List, tree, or counting principle. They're all good methods. It's just that some methods are easier than others depending on the question. But go ahead and take a moment to review those. Then when you're ready, go ahead and press play again and let's try some more. These next 3 questions you have in your packet also, and you actually have them twice. The first time I'm doing branch and list, and then the second time I'm doing counting principle. So for this video, I'm going to go ahead and do counting principle for all 3 of these. But if you want to see list or tree diagram, they are in your packet, and you can see those in the answer parts on the backs of the pages. But let's go ahead and look at number 2. If LaQuisha can enter school by any one of 3 doors, and the school has 2 staircases to the second floor, how many different ways can LaQuisha reach a room on the second floor? Well, she has to go through a door, and she has to go up a staircase, right? There's 2 different options. So the first one, the door, there are 3 different doors she could choose from. The second one, the staircase, there are 2 that she could choose from. So how many possibilities exist? 6 different ways that she can get to the second floor. Number 3, Kimberly has 3 pair of pants, 1 black, 1 red, 1 tan. She also has 4 shirts, 1 pink, 1 white, 1 yellow, and 1 green. How many possible outfits can Kimberly wear if each outfit consists of 1 pair of pants and 1 shirt? So we're looking at pants times shirts. So our first box is going to be our pants box. And she's got 1, 2, 3 possible pant colors. The next one's going to be the shirts. And she has 1, 2, 3, 4 possible shirt colors. So how many colors can she make? She can make 12 outfit combos out of all of her colors. Now these first 2 that we've done, we're only looking at those 2 categories, right? Doors and stairs, pants and shirts. But there can be a lot of different categories. Like with the Grimaldis, we had 3 categories because we had first child, middle child, youngest child. So when we look at number 4 with Sam buying his new car, we see 1 category is the body style, the convertible or the hatchback. The next category is the colors, red, white, and blue. And the last category is the transmission. So I'm going to go ahead and do my numbers and do my multiplying here on the screen, but I'm not going to explain it. I want you to try it on your own on your paper, and let's see if we get to the same answer. How did you do? Our first combo was that body type, the convertible or the hatchback. Our second were the three colors, red, white, and blue. And our third was the type of transmission, automatic or standard. And when we do 2 times 3 times 2, that gets us to 12 possible combinations. So you're seeing the same kind of question every single time. How many possible combinations? How many possible outfits? How many possible ways? How many possible arrangements? Those are all sample space questions. And we can do lists or trees or the counting principle. So now you have 6 problems that you can try on your own. I want you to go ahead and pause the video. You can choose whatever method you want. You've got your 3 to choose from, lists, trees, or counting principle. Pause the video now, and when you come back, we can do number 6 together because I'm thinking that one might trip you up just a little bit. Okay, so if you tried number 6, you realize you end up with a crazy big number. But let's go ahead and do it together. Your state issues license plates consisting of letters and numbers. There are 26 letters and 10 numbers available because we've got 0 through 9, right? That gives us the 10 numbers. And they can be repeated. How many possible license plate combinations can be issued with 2 letters followed by 3 numbers? These are our categories. So, when we're thinking about what we are multiplying, we're going to have our first space, which is a letter, our second space, which is a letter, our third space, which is a number, our fourth space, which is a number, and our fifth space, which is a number. So we've got letter combos for the first 2 and number combos for the last 3. Now they already tell us there are 26 letters. So our first one, there's 26 letters to choose from. They also tell us things can be repeated. So the second letter could be the same letter as the first one, which means we have 26 letters still available. If they told us it could not be repeated, that would be a 25 in the second category, but they can be. The numbers, they tell us there are 10. And we can repeat, which means there will be 10 possibilities, all 3 spaces. So we grab our calculator, we do 26 times 26 times 10 times 10 times 10, and that's going to give us 676,000. I am so thankful that we have the counting principle to help us out. That's our sample spaces probability lesson. I hope today was a good day for you. Remember, I will see you back when I come back to class. So if you have any questions over this video or over the questions as you work on them, go ahead and bring them back to class and let's talk them through together the next time we see each other. Have a great week. I'll talk to you soon.